This section is called special products. There are actually exactly two special products that we're going to be looking at in this section. Remember that product is just a special word for what you get when you multiply. In the last section, one of the things we did was learn how to multiply two binomials, like these ones. When you multiply binomials, you can think of distributing each of the terms in the first binomial across each of the terms in the second binomial. In fact, this will work for multiplying any two polynomials. In this case, I'd get x times x plus x times 3. And 2 times x plus 2 times 3. And then I can combine like terms. There's nothing special or new here. This is exactly what we were doing in the last section. But what if I give you a question like this one? X plus 2 times x plus 2 again. In other words, what if the two binomials are identical? Well, so what? We can proceed by multiplying x by x and then x by 2. And then 2 times x and 2 times 2. Combining like terms gives me x squared plus 4x plus 4. So why are we even spending the time looking at this? Well, there are a lot of different reasons, and some of them may not be obvious until much later in this course or later in your career. But one thing to notice is that I can write x plus 2 times x plus 2 again, or x plus 2 times itself, as x plus 2 squared. We'll do a few examples so that you can see the pattern a little more clearly, but it turns out that whenever you run into something plus something all squared, your answer is going to end up being the first thing squared plus the second thing squared. But remember that squared means times itself. We've still got these inner and outer terms. We're going to have a middle term that, when combined, gives us 2 times the first thing times the second thing. So this is the shortcut that we're working towards. But I want to emphasize here that it's not necessary to memorize this shortcut. I think it'll fall out naturally. Eventually, you'll get used to seeing something that looks like this and just turning it into something that looks like this. But practice is the best way to get there. The really critical piece is recognizing that A plus B, any A and any B, when you square that sum, you're not just squaring A and separately squaring B. These are not equal. This is a huge, big red flag error. Don't do this. A plus B, when you square it, means A plus B times itself. And that's the really big, important takeaway from this part of this section. Let's do a few more examples now, but keep this in mind. A plus B, or x plus y, or t plus 3, when you square it, gives you that binomial times itself. Okay, here's an example. X plus 5 squared means x plus 5 times itself. Now, once you've got it rewritten like that, it's really easy to see that this is just a case of the first term in the first polynomial times all of the terms in the second polynomial. X times x is x squared. X times 5 is 5x. And 5, the second term, times both of the terms in the second polynomial. So we need to add 5x and 25, and then combine like terms. Notice that if I'd used the shortcut, I could have rewritten this problem this way. X plus 5 squared is x corresponds to a, so instead of a squared, I'll write x squared, plus 2 times a, which is x, times b, which corresponds with 5, plus 5b, or 5 squared. And this would give me x squared plus 10x plus 25. That's the same thing as I got here. It works because when the pieces inside the two binomials are identical, you're going to get a copy of 5 times x from here and a copy of 5 times x from here. You're going to get 2 copies of 5 times x, 2 copies of 5 times x, or 2 copies of a times b, 5 times x. Here's another one, 3x plus 2 squared. 3x plus 2 squared means 3x plus 2 times itself. Using distribution, I get 3x times 3x, which is 9x squared, plus 3x times 2, which is 6x, plus, now I'm done with the 3x, let's move to the 2. 2 times 3x, which is 6x, and these two are the same, because these two are the same. Finally, 2 times 2, which is 4. Combining my two like middle terms, I get 12x instead of 2 copies of 6x. Using the shortcut, recognize first of all what corresponds to what. A corresponds to 3x, all of this. B corresponds to just 2. So I could have written this as a squared, well, a is 3x, so that goes in there, plus 2 times a times b. A corresponds to 3x, b corresponds to 2, plus b squared. B corresponds with 2. Now I need to tidy this up. Here I need to remember my rule for exponents that says if I have a product raised to a power, I can write it as the first factor to the power times the second factor to the power. Here my a is 3, and my b is x, and the power, r, is 2. So this first term can be written as 3 squared, x squared. The next term can be written as 2 times 3 times 2, that's 6 times 2, or 12, times x. And the last term is 2 squared, or 4. Finally, I can write 3 squared as 9, so I'll tidy that up as well. There's my answer using the shortcut. But notice, it's the same as the answer I got simply by using distribution. It doesn't actually matter which technique you use. And in fact, at first, I'd like to encourage you to continue using distribution. When we memorize a shortcut too soon, in the process of our understanding a new idea. The memorization takes up space in our memory that's much better put to use understanding the fundamental algebra. So I don't mind which of these techniques you use, but notice that the shortcut only works on a binomial squared. It's a special case. I can either write this using the shortcut, or I can go back to first principles and say, what does this mean? It means 3x plus 2 times itself, and then just use distribution to multiply two binomials. Here's our next example. 2x minus 3 squared means 2x minus 3 times itself. Using distribution, I get 2x times 2x. 2 times 2 is 4. X times x is x squared. Then 2x times negative 3. You don't have to write plus the opposite. You don't have to write plus negative 3. But if these are the first few problems like this you've done, it can be helpful. 2x times negative 3 is negative 6x. I've multiplied everything over here by 2x. Now I need to multiply everything over here by negative 3. Negative 3 times 2x is negative 6x. Negative 3 times negative 3 is positive 9. Combining like terms, here's my answer. 2x minus 3 squared, using the shortcut. First, let's identify what our a and our b are. A is 2x. B is negative 3. Now I'm ready to do the work. A plus b squared is a squared plus 2 times a times b plus b squared. But a was 2x. And b is negative 3. Using the product property for exponents again, here I get 2 squared x squared plus 2 times 2 times negative 3. 4 times negative 3 times x plus negative 3 times negative 3 is positive 9. 2 squared is 4, plus negative 12x is the same as minus 12x, plus 9. And my answers match. Two different techniques. This one's great. It's a nice pattern to recognize. But you can always use this, even if the two binomials you're multiplying are not identical. Here they are, so we have a choice. But if we don't have a choice, we can always revert to this method.